Example number 4 is that special case that we talked about at the very, very beginning. We talked through the first step of graphing linear equations was to make a table of values. And it wanted 5 points total, 2 negative, 2 positive, and 0 as your domain or as your x values. And we said that we usually use negative 2, negative 1, 0, 1, and 2. However, if there's a fraction in front of x, use multiples, remember we multiply to get multiples, of the denominator to get rid of the fraction, or to cross-reduce. So what we're saying is we're going to use multiples of 2 as our x values. So we've always got 0. The first multiple of 2 is 2, and then 2 times 2 is 4, so the second multiple is 4. And then I'm just going to use the opposite of those for my negative values, negative 2 and negative 4. So using values of negative 4, negative 2, 0, 2, and 4 will help us get rid of that fraction. That's what values we're going to use for x so that our multiplication is easier and we get whole numbers for y as opposed to fractions, which can sometimes be a little more difficult to graph. So what I'm saying here, you'll see 1/2 times x. If I do 1/2 times negative 4, 1/2 of negative 4 is negative 2. 1/2 times negative 2, that's like negative 2 over 1. The 2's would cross-reduce to be 1 and 1, and then a negative times a positive is a negative 1. 1/2 times 0 is 0, because any number times 0 is 0. 1/2 times 2, or 2 over 1, remember that the 2's will cross-reduce to be 1 and 1, and a positive times positive is just positive 1. And then 1/2 times 4, we can put 4 over 1, any whole number over 1. And again, because 4 is a multiple of 2, these two numbers can cross-reduce so that 2 goes into 2 once and 2 goes into 4 twice. When I multiply straight across, I get 2 over 1, or 2. And so now I have these nice whole numbers for y instead of decimal or fraction answers, which just make it easier to graph in the long run. So this, you don't have to use negative 4, negative 2, 0, 2, and 4, but I would think that it does make things a lot easier in the long run. So negative 4, negative 2, negative 2, negative 1, 0, 0, 2, 1, and 4, 2 are my points that I'm going to plot on my graph. So I'm going to go left 2 and down 2, left 2, down 1, 0, 0 is at the origin. 2, 1 means I'm going to go right 2 and up 1, and then right 4 and up 2. I've got my 5 points that all fall in a line, so I am going to use a straight edge or ruler to help me get those all connected. And I'm going to extend my line past the coordinate plane so it goes all the way through the graph and all the way to the outside to this white space on the outside. I can add my arrows. I can add labels to my points. So negative 4, negative 2, negative 2, negative 1, 0, 0, 2, 1, and 4, 2. And then I can label my line with the equation of y equals 1/2 x. And so that goes with this line. That's the line that I just graphed. I graphed this line using this equation. And it is linear, so I circled linear up here at the top. And then this last one, again, I want you to fill in on your own. Describe any patterns you notice in your table. What do you notice about things? It's going up by 2's, and then what's happening to y. How is this different from graph 1 and example 1? Again, I'm not going to write anything for this little part, but I want you to write something to share in class. So all of these table talk parts, even though I did not write something, you should be writing something and comparing them to example 1 on the front side here as to patterns and how that changes your graph and how that changes your table.